Yeah, good afternoon. We'll talk about like cognitive functioning and mouse movement today, and it is also an ongoing project. So I will also only talk about like main ideas today. So in detail, we are investigating how can machine learning models predict cognitive functioning scores using demographic and mouse movement features, and which features are most influential. Cognitive functioning is critical for understanding human behavior and health, but traditional assessment methods can be time-consuming. Our research explores whether machine learning can offer a more efficient method by using demographic and mouse movement data. And the goal is twofold. First, to develop predictive models that estimate cognitive scores, and second, to identify which features such as age, education, or specific mouse movements metrics collected from surveys are most influential in those predictions. Like first, mild cognitive impairment, or MCI in short, it is a condition where individuals experience more memory or thinking problems than others as they age, but not too bad to influence significantly that way's daily life. People with MCI often face memory issues such as forgetting appointments or recent conversations. They may also struggle with complex tasks like manage finances or planning events. However, unlike dementia, individuals with MCI generally maintain their independence in daily activities such as dressing, cooking, or driving. MCI is an important condition to study because it can be a precursor to more serious cognitive disorders. However, not everybody with MCI progresses to dementia, like some remain stable or even improve over time. So early detection and intervention are key to manage MCI and improve daily quality. And we're exploring how mouse movements during service can serve as a window into cognitive process. By tracking metrics like cursor position, speed, and clicks, we can have insights into how presidents engage and process survey questions. For example, patterns of movements such as hesitation, slow cursor speed, or back and forth motions can uncover mental workload. When facing with difficult questions, respondents may show increased hesitation, reflecting deeper cognitive processing. Repeated clicks or long pauses may signal uncertainty or difficulty in choosing between options. Those subtle behavior cues go beyond traditional survey responses, offering a richer understanding of how people think and make decisions. On the demographic side, variables like gender, age, education, race, marriage status, labor status, and household income provide essential targets of individuals. On the other hand, mouse movement features such as X or Y flips, response time, idle time, initial time, hovers, total distance, or speed offer insights of cognitive processes. For instance, longer response time or frequent hovers might indicate hesitation or deeper thought, while faster movements could reflect confidence or familiarity. By combining those two data sources, we hope to uncover richer insights into how those features could reflect personal cognitive functioning. And we use the mouse tracking data, which are collected via the UAS 618 survey, which focused on three key topics: health, income, and subjective well-being. To ensure data quality, we excluded incomplete surveys and incomplete mouse tracking data. Additionally, we removed data from touch or mobile devices because these platforms can introduce variability in response patterns. The machine learning algorithms learn patterns from data to make predictions. In this study, we use labeled data such as demographic variables like age, education, income, and mouse movement features like response time, speed, hovers. and survey responses to train models like deep neural networks to analyze the input data to identify patterns associated with MCI. And our outcome is called PCI score, which is a continuous score from 0 to 1, quantifying the probability of cognitive impairment proposed by UAS experts. Then I will introduce Shapley value, a powerful concept from game theory that is now widely used in explainable machine learning. The Shapley value fairly distributes the total payout among players based on their individual contributions. In machine learning, this translates to measure the average marginal contribution of each feature, such as age, mouse movement, speed, or survey responses across all possible combination of features. For example, in predicting PCI, the Shapley values can help us to understand how much each feature, like response time or education level, influences the model's prediction. This allows us to identify the most important factors driving the outcome. And at the end, we have open questions in our project on predicting the PCI score using machine learning and Shapley values. First, what are reasonable classification thresholds for PCI? Determining the optimal threshold for classifying individuals at risk or not is critical in potential applications. And second, how can Shapley value address potential biases in data sets? For example, biases related to age or gender could screw predictions. Can Shapley value help identify and mitigate those biases, ensuring more equitable models? And final one, can Shapley value effectively capture changes in feature importance over time? In longitudinal studies of cognitive functioning, the importance of features like mouse movement patterns or demographic factors may evolve. Can Shapley values adapt those dynamics and provide insights in how cognitive health change over time? Yeah, thanks for your attention.